Welcome to Qubits 2020. I'm Jen Houston, Senior Vice President of Global Marketing and Public Affairs at D-Wave. We are so glad you've joined us today. What started as a small conference with a small amount of researchers 6 years ago is today a global event where entrepreneurs, enterprises, developers, and people who are curious about quantum computing have all joined together to learn more. That's what we invite you to do today, learn more. We'll have speeches from big brands, small brands, rule breakers, entrepreneurs, people like you who care deeply about learning and driving quantum computing forward. We have built this conference to be one of connection. We've established chat rooms and virtual events for you all day long so that you can experience others' experience of quantum computing. We've set up this virtual platform in a way that allows you to engage with the presenters as they're presenting. We're curious about what you're curious about, and we're thrilled that you're here today.
The future doesn't belong to those who follow the familiar. It belongs to the disruptors, risk-takers, renegades. It belongs to the outliers. Because innovation thrives at the edge, and so does D-Wave quantum computing. Using D-Wave, people like you are doing amazing things, creating faster ways to optimize, smarter ways to move, and better ways to live. Together, we are writing new rules, helping the world adapt, connect, and thrive. After all, the future is in our hands. Welcome to the D-Wave Qubits Conference. Faster forward.
Hello, my name is Alan Baratz, and I'm the CEO at D-Wave Systems. Welcome to our 8th Qubits Conference, and thanks to all of you for taking the time to be here with us today. For those of you who have been with us before, you can already see that this time Qubits is different. It's different because we're virtual, and we're virtual because we want to help protect the health and safety of all of us. But one thing hasn't changed, and that's connection. Qubits is always about connecting. It's about connecting you, our customers, our partners, our developers, our users, connecting you with one another, connecting you with D-Wave, connecting you with the emerging quantum ecosystem, and connecting you with quantum computing. And we've worked really hard to ensure that even within this virtual environment, you have plenty of opportunity to meet one another, to discuss, to debate, and to build relationships. But there's one other reason why Qubits is different this year. And that is because we're also using Qubits as a platform to launch our exciting new products, beginning with our new 5,000 qubit Advantage quantum computer. This is the first quantum computer built for business, designed specifically to solve large, complex, real-world business problems, and to solve them in a production environment. You know, it's been a 10-year journey for many of us. Early on, they said a quantum computer couldn't be built, but we committed. Then they said our approach was wrong, but we remained committed. More recently, we've heard it'll be at least 10 years before you can run business applications on a quantum computer. But today, we've changed that. Today, with the Advantage 5,000 qubit quantum computer, we're open for business. Businesses now have the ability to run real-world complex applications on the D-Wave Advantage quantum computer. This is for all of you, for the believers, the renegades, the outliers. So let's get into it. This morning, the brand new 5,000 qubit Advantage quantum computer went online in our Leap quantum cloud service. Anybody can go to Leap and get immediate real-time access to the Advantage quantum computer. The Advantage quantum computer has 5,000 qubits. That's over double the number of qubits in our previous 2,000 qubit quantum computer. It also has over twice the connectivity. Every qubit in the Advantage system is connected to 15 others. That's 2.5 times the connectivity of our previous system, where each qubit was connected to only 6 others. The combination of twice the number of qubits with over twice the connectivity is what allows us to run much larger, much more complex real-world problems. But there's one more important point about the advantage quantum computer. With 2 times the number of qubits, and with over 2 times the connectivity, and with 5 times the number of devices on the superconducting quantum processor, we're still able to program the system in the same amount of time and read out the results in the same amount of time, and we're able to run it at the same temperature. What this means is that our technology scales. And it scales despite the so-called experts who said that the D-Wave technology wouldn't scale. And I promise you, we are going to continue scaling the technology into the future. In a few minutes, Mark Johnson, who is our Vice President of Processor Design and Development and Quantum Products, will tell you how the new Advantage quantum computer was re-engineered from the ground up, specifically to support business applications. But it's not just about hardware and systems. It's also about software. Last February, we launched the second major release of our quantum cloud service, Leap. Within Leap 2, we introduced our hybrid solver service, a technology that brings together classical computing resources with our quantum computer, working hand in glove to be able to solve problems that are much larger than what can be solved natively on the quantum computer. The first version of our hybrid solver service, introduced last February, could solve problems with up to 10,000 variables. But today, we have upgraded the hybrid solver service. The hybrid solver service, backed by Advantage quantum computer, is now able to solve problems with up to 1 million variables, truly production scale applications. But there's a second new advance in the hybrid solver service. Up until now, our quantum computer and our hybrid solver supported problems with binary variables. These are variables that can take on a value of 0 or 1. However, not all problems are binary. Many problems have variables that go beyond binary. For example, discrete, a problem where the variables take on a value from a set of possible values. Maybe one of the numbers in the set 1, 2, 3, 4, 5, or one of the colors in the set red, green, yellow, blue. Well, next week, we will be introducing within Leap a new discrete model solver. What this means is that you no longer need to figure out how to transform your problem into a binary problem. You can solve it natively as a discrete problem. We call this our discrete quadratic solver. And that will be available in Leap next week. About 3 or 4 months ago, we opened up our quantum computer for free, unlimited use by anybody doing COVID research. And we learned something important from that. What we learned is that while our software is very good, and our tools are very powerful, and we have great training modules, we learned that our customers need help. They need help understanding which problems can best be solved by a quantum computer. They need help understanding how to best formulate their problems to be solved on the D-Wave quantum computer. Well, today we are also announcing D-Wave Launch, a quick start to get help from experts in understanding how to best use the D-Wave quantum computer. It's really easy to use D-Wave Launch. All you need to do is go to our website, dwavesys.com, and click on D-Wave Launch. The information you provide in that form will allow us to decide who would be best to help you figure out how to use our quantum computer. It might be one of our expert application developers within D-Wave, or it might be one of the experts in one of our hand-picked partners like Accenture, with global expertise in a broad array of markets, industries, and application areas. So, in summary, today we're announcing our new 5,000 qubit Advantage quantum computer, our new hybrid solver service capable of supporting up to 1 million variables, and next week, discrete variables in addition to binary variables, and D-Wave Launch to help you get started understanding how to get the most out of D-Wave's quantum computer and quantum computing technologies. Now, I'm going to turn it over to Alex Condello in Vancouver. Alex is responsible for tools, algorithms, and applications, and he's going to give you a demo of the new 5,000 qubit Advantage quantum computer, the new version 2 of our hybrid solver service, and some exciting real-world applications. Over to you, Alex.
Thanks, Alan. My name is Alex Condello, and I'm the Manager of Applications Development, Technologies, and Tools here at D-Wave System. And today, I'm going to be doing a live demo showing how to use our hybrid and quantum resources for solving real problems at scale. So I'm going to start off here in Leap. For a lot of you, I think you've probably seen Leap before, but for those of you who haven't, this is our online platform for quantum computing. There's a lot of great features in Leap, most of which I don't unfortunately have time to go into today, but I'll just run by them really quickly. So the first one is I can see things like how much solver access I have, what solvers I have access to, problems I've submitted. You'll notice that I have access here at the bottom to an Advantage system. That's new as of today. But what I want to go to next is our set of examples. So in Leap, we have a curated set of examples that are built for you to understand how to use quantum computing and hybrid computing for real problems today. These problems are all chosen to be recognizable to you. Things like nurse scheduling, pipeline monitoring, satellite placement. These are all practical problems that people have used our quantum and hybrid solvers to solve. I'm going to go ahead and pick one, which is our antennas problem. And I'm going to load that up in our online IDE available in Leap. This IDE is going to come pre-installed with our Ocean tools, with an inspector, and with everything else that you need to run a quantum computing program right away. So as you can see here, I have our antennas example that I just loaded. And I can go ahead and run this right away, simply by opening a terminal. This has everything that I need. This has Python installed, as I mentioned. It has all the tools. This is a fully functioning Python environment. And I can just go ahead and run this demo right away. When I do this, this is making a call to our Advantage system live, right here in front of everyone. And lo and behold, our Advantage system was able to find the solution to this problem. Now, so far I've been talking about problems that are relatively small in scale and are able to be fit directly on a quantum computer. But we all know that real practical problems at customer scale are large. And large problems require hybrid solutions. So hybrid is the best of classical and quantum together. And I'm going to show a demo of solving a practical problem using hybrid. So let's go ahead and take a look at a resource distribution problem. Resource optimization is a very common problem in lots of different industrial optimization spaces. And it's especially relevant today with the COVID-19 pandemic. The problem is this. Imagine you have a collection of hospitals. These hospitals have either a shortage or a surplus of resources. I would like to take my collection of hospitals and put them into small pods in such a way that each pod has a net surplus of resources. And I want to do it such that each of these pods are relatively easy to share resources amongst. So think nearby. So let's go ahead and pop over to a little visual representation of what I'm talking about. So here, we have an image of a map of New York. What we've done is we've taken a public data set that has the locations of a collection of hospitals, and we've generated some shortages and surpluses in those hospitals based on their size. So you can see here, here's a collection of hospitals. Blue circles represent surpluses. Red circles represent shortages. And the size of the circle represents how much of a shortage or surplus there is. I'll mention that our hybrid solver, this demo actually works for quite a bit bigger maps. Before I was just looking at New York, but I can actually zoom this out to a big chunk of the eastern seaboard by looking at 1,000 hospitals. And our hybrid solver can handle problems of this scale. But because I have a relatively short demo, I'm going to keep this relatively small so that we can run it here, and I'll focus on just New York. what I want to do is I want to take this collection of hospitals and I want to partition them into groups of size 4. So you can see here we have a partition size of 4. I also want to limit the number of neighbors that each hospital can connect to. So each hospital can only look at its 8 nearest neighbors as potential partners. This is a reasonable thing to do because you wouldn't want to, say, pair a hospital in the middle of New York with a hospital in Chicago. There's some other things that I can tune. For instance, I can tune how much I want to care about the cost of shipping between the hospitals, think the distance, and how much I want to emphasize the degree of surplus for each hospital. This is all tunable, but I'm just going to go ahead and jump to solving this problem with the settings as currently set. So let's go ahead and run this on our Leap hybrid sampler. So I've just hit run. A problem has been submitted to our server-side Leap hybrid sampler. This is a sampler that is backed by Advantage that uses the best of both quantum and classical resources to solve problems at scale. These problems are large, these problems are difficult, and they need both classical and quantum in order to get the benefits of both and truly reach the full potential of solving. So you can see here it's found a solution. The hospitals have been grouped. You can see that there's a group of 4 here and a group of 4 here and here. And there's some data about what we did. So this is sort of the cost of shipment, and this is the total utility that are gotten. So in real time, right now, using a hybrid system, I was able to solve this problem and make the best use of both classical and quantum together. Just for comparison, I'm going to try running this on one of our classical solvers. Now, these classical solvers come with Ocean. They're there for you to play with and to test. They run purely classically. In this case, it's running in the cloud. And I'll mention that this isn't a benchmarking study I'm doing here. That Kathy will be giving a talk later about benchmarking. This is simply comparing one BQM solver to another, hybrid to classical. And when I did that, you can see that the Taboo sampler was able to solve the problem, but it's not quite as good a solution as was able to be found by the quantum computer, and it took a little bit more time. So specifically, you can see here that the utility was quite a bit lower. It was a bit cheaper, but the overall energy was higher, and it took longer to solve. So I hope what I've shown today is that you can use Leap and our online IDE to get started with quantum easily and quickly with our fully featured environment that you can use to build practical problems and practical solutions, and that you can use our hybrid solvers to solve real practical problems today at scale using the best of quantum and classical. Thanks everyone for listening. Back to you, Alan.
Thanks, Alex. That was amazing. Now let's get started with the Qubits program. You're going to hear a little bit more from D-Wave, a little bit more about the Advantage quantum computer and some benchmarking results on that system. You're going to hear a bit more about our hybrid solver service and about applications. But more importantly, you're going to hear from our customers. You're going to hear from our customers working on business-critical applications, some of them just about ready to go into production, and some of them on their path to production. So now let's go hear from some of our customers.
What Advantage gives us is the ability to seamlessly integrate quantum into our business problems. We have in excess of 4 million different decision variables that all have interactions with each other. We've been able to decrease the amount of time to get a result from 25 hours down to seconds. So now quantum computing isn't something that we can use once a year or once in a while. We can use it on a daily basis embedded into our business solutions.
The main application that we work on is doing quantum chemistry simulations. One of the biggest things that made us work with D-Wave system is actually the accuracy of the results. We always get very precise calculations.
We used a D-Wave machine to determine the allocation of the TV commercials to maximize the brand recognition of the viewers. Our optimized version gets better sales lift compared to the conventional one.
Using D-Wave's quantum computers, we've been able to solve real protein design problems on quantum hardware.
なのでオフィスとリモートワークどちらにした方が良いか、そして全社的な制限であるとかチーム内の制約いくつかあるんですけれども、それも同時に加味して最適なスケジュールを提案するニューノーマルスケジューラーというサービスアプリケーションを展開しています。
So what surprised me about Advantage and the quantum system with D-Wave is really the simplicity and the ability to integrate our knowledge into a system that we're unfamiliar with and get a prototype and a project into production in a matter of 2 months is phenomenal.
We solved very complicated and large-scale vehicle routing problem. And we see that DF hybrid system shows a very non-trivial and good solution.
実際に使えるということはですね、百聞は一見にしかずではないんですけど、多くの気づきがありまして、それによって、実際に我々がどこに、量子コンピューティングの力を使っていくかということが分かってまいりました。
So our goal is to really use the new hybrid solver service and this particular application of the paint shop to establish the first real like autonomously running production application of quantum computing in an existing factory.
D-Wave はですね、常に先進の技術開発を行っており、私たちが行き詰まりを感じている時もですね、きっとこの壁を越えることができるということを示し続けているというふうに感じています。
What makes me really excited about quantum is its exponential nature. When we double the capacity of our quantum system, we're actually squaring the actual output or power of the computation. And so we never had really access to this kind of exponential technology before. And the possibilities are really unimaginable.